So Dr. Vincent Cheng is a NARUP Fellow and Director of Sustainability. He's in charge of East Asia. So ARUP is a British multinational firm of advisory, architecture, design, planning, engineering, and project management all around the world. Vincent, I know that you are an industry-renowned sustainability expert. You are specialized in sustainable master planning and infrastructure. You are specialized in district energy, in integrated sustainability design, and also in healthy and smart design. So you have many expertise and many experience. So I think it will be very fruitful and interesting to follow you. Today, you will present us the next wave of building decarbonization. And I think now everyone is looking forward to listening to your presentation. So I give you the floor, Vincent. And thank you again for your participation.
Thanks, Frederick, for your kind introduction and also having me here this morning. And good morning, everyone. It's really my pleasure and honor to share our experience. It's only about myself, actually about the company and also these regions in particular on the kind of this decarbonization wave. I mean, although it's not new, but I think this wave will be much significant and bigger than the previous initiative that we help to save the world.
We can see your screen.
Okay, let me. Okay, so I choose my topic to be, as I said, the next wave because we know that decarbonization in the building is not new at all, and that's been kind of key agenda in the past few or one at least decades. So that's why today I'd like to share our recent experience, what's actually next, and what we believe will be kind of futures in these areas. But in particular, there are some questions being asked, with the big questions in the industry around this decarbonizations and more importantly, how we can create a more sustainable, livable and healthy built environments without jeopardizing the resources, depletions of the resources, and I think more importantly, that the society or the world can be built environment can be regenerative. So these are the questions that I hope I can provide some answer. If not, probably that throughout the Q&A session that we can discuss more. As I said, that this is actually cascade down from a very high level international agenda, that be it SDG or COP 21, that Paris agreements that actually help the world actually work together in what we call common kind of agendas. In particular, in recent month, we hear a lot in this regions that most major economies, be it China, Japan, Korea, Singapore, and others, have made their commitments that they want to be, carbon neutralities by 2050s. Some other less developed, I would say, economy like Vietnam, Thailand, the Philippines, and also India. They also make the kind of similar, although not as aggressive, which they hope actually can help to curb the carbon emissions. So out of this kind of high-level policy or agendas, that industry actually come up with a lot of tools and help to help us to move forward in these directions. Well, in particular, that we heard a lot on this green certifications or zero carbon compute certifications that actually help to create the kind of standards for industry to follow on. So quick kind of idea on what's actually is the kind of context in Asia. We know that, I mean, here in Asia, that although not as developed as Europe or in the United States, but our kind of carbon footprint is actually as high. In particular, those economies that will have a kind of industry, developed industry, like Taiwan or Korea, even Japan, their kind of carbon footprint are very high, and that because other than the kind of daily activities, that they also have a certain kind of industrial activities that to sustain their kind of life, but and also produce the kind of materials that being consumed other places. So it's not difficult to imagine that in a city in this world in particular, that I mean that you have this kind of composition of our the carbon footprint. Although that in the industry and also agriculture, to some extent, form some part of the footprint, but still that for those more developed economy, buildings still be the key, I would say, sector that emits a lot of carbon. So if we want to help to curb, to reduce the carbon emissions, building still will be the key focus on that. Well, in particular, if you look closer and the kind of carbon footprint of Hong Kong, where it could be quite typical in terms of the lifestyle, the use of materials, and I think more importantly, the way how we produce and use energy can tell the pictures. Here, I mean, you can see that, I mean, that out of this carbon footprint, 67% are actually coming from the generation of electricity. But right now, we use still 50% of coal and then 50% of natural gas to produce the electricity, and transport and also waste are also form a significant part of that carbon emissions. And in particular, if you look closer in that electricity consumption, you can find that commercial building actually consume a significant amount of our electricity, because for international city like Hong Kong, there are a lot of business activity happening in offices, and also a lot of activity on the shopping mall. So that's why, I mean, that commercial facility actually account for over 60% of the total electricity. So I think if you want to solve the problem, we have to look into this broad perspective, and also in inequalities on how this electricity being used within the building sector. So that's why in this region that and most the government actually has developed policy on the energy efficiency. I mean, these is a kind of a summary on the kind of instrument that they typically use, including using regulations, using market green certifications, and setting the kind of targets for existing building reduction, and more and more kind of become popular is to use some incentive and kind of disclosure of energy use from buildings and also from the corporate levels, in order to create the kind of peer pressures, for the operators to behave. So I mean that you can see in the table here that different city in this region use different methods. Some use mandatory, some use voluntary, to help to implement this kind of initiative out of this energy efficiency frameworks. So basically, these show the overall kind of frameworks of our energy efficiency or energy building energy efficiency. Well, we use, of course, building energy costs to control the way how we build our built environments, and also the system, subsystem within the building. And we also, incentivize the markets to creating the kind of green buildings measures, and more recently, for existing building in particular, to create a market whereby the building operators or building energy operators have the chance actually to invest in this particular market in order to retrofit commissioning the building and to maintain it to the very kind of high standard level. Bear in mind that we still, I would say, in this region, over 60%, over 80% of those buildings are below the kind of current energy standard. So we still have a long way to go to make these existing buildings as performance as the new buildings. So these are some details on the kind of instruments that have been used in leading city in this region. In Japan in particular, you probably have heard that they use a CASB to help to plan and also to design green building. They use this top runner program to encourage the building owner, to reduce the carbon by make it kind of voluntary kind of disclosure on the performance, and more importantly, that the metropolitan city of Tokyo actually introduced a cap and trade program whereby the building actually they can trade the kind of energy saving that they generate out of the initiative. So they actually proved to be very effective. We were told by the local authorities that over 30% of actually energy is being reduced because of this kind of a cap and trade program. In Singapore, that of course that they also take a quite active or proactive measures to control the energy and also the building design. Green Mark, it's the kind of a green building certifications exercise. They also have a very stringent kind of energy code, and that actually help to reduce the energy generated by the new building. And more recently, they actually introduced this super low energy building schemes where they encourage the building owner to take extra methods or measures to reduce the existing building performance. Likewise, in Hong Kong, we have this green certifications scheme we call BIM Plus, and then we actually from time to time we tighten up our building energy code and make the energy audits and carbon audits mandatory, and the government actually take a leading role to basically lead by model to have all the kind of public fund buildings been achieving at least gold standards of this BIM Plus requirements. And we also regulate the kind of electrical appliances used in the household in order to reduce the carbon or energy emissions from the residential buildings. So you ask what exactly is zero carbon buildings? I think these are the kind of I would say quite well accepted kind of definitions of carbon emissions profile. That we know that at the construction process, we will create a lot of energy, use a lot of energy, and use a lot of materials in situ. They actually will form kind of embedded kind of carbons in the buildings. And I think more importantly, it drops the life cycle of the building. We're talking about 80 or even longer kind of operating life of the buildings that the commercial buildings should use a lot of energies for to operate by providing comfortable space like the thermal comforts, air quality control, and also lighting controls. So throughout the life cycle, we have a lot of works also need to repair and replenish a kind of wear and tear of the building in order to maintain its kind of operabilities and well-being, not only the building itself but also people. So that's why that this kind of maintenance or the operational stage is very important. And in fact, I mean that these days in this region that we talk a lot on how we can incentivize the practice of retrofit commissioning to use some technologies like AI to create kind of preventive kind of maintenance process, so that the building can stay young and also efficient as long as possible. So these, but we still need to get into the fact, I mean, that we still have around 50% of those carbon being embedded in the material we use. So when we say about net zero, we are not only talking about offset the operating stage. We have to think about the embedded carbon as well. So overall, that I think we are talking about the decarbonizations process to the state that we have to create kind of we call it positive building, energy positive building, meaning that the energy generated throughout the operating stage has to be able also to offset the kind of embodied carbon that embedded in the materials. So there are actually a lot of methods, or a lot of standards being developed, as I said, in this region or worldwide, to help the designer, engineer, building operators to take on board on the design and also operating of the system, well, including using some passive strategies, active system, and some renewal system. But I think there's something that we have to work more in order to achieve that. I mean, it's actually it's told by this diagram that we have to work from both ends. First is that we have to reduce. That's very important from the supply side, and based on calculations, science-based calculations, we need to reduce at least 60% of our current kind of operating demand, energy demand across all the building sector. I mean, that be it residential or the commercial kind of sectors. So it's actually very challenging. That bear in mind that there still have kind of residual energy that needs to provide in order to provide the kind of basic necessity that can safeguard the health and well-being of people. So that 60% is very kind of challenging. But on the other hand, that is equally also challenging is to increase renewable energy supply. But if you look at the context of the built environment, in particular, those developed kind of a city like Hong Kong, Singapore, Tokyo, Taiwan, or Beijing, it's very difficult, to install this kind of a renewable in the city. So we have to find some other way, which later I'll show you our kind of idea that generated recently, in order to maximize the kind of available provisions to create renewable energy. So the end game is by 2050 that we will approach this kind of balance on the supply and also demand efforts in order to achieve that zero carbon objectives. So just quickly give you some idea of what actually has been done, in the past, I would say decades, on this zero carbon front. Actually, as I said, zero carbon building is not new in this region. In fact, this is the first zero carbon project I've been working on 10 years ago for Samsung, that company that they actually construct or build this demonstration projects that call it Green Tomorrow, to demonstrate then the technology to achieve the zero emissions, both in the energy and also on the waste, solid waste, and also on the liquid waste. So on that project, we actually have applied a lot of then state-of-the-art technology, including what the Samsung, the company, best on, which is the electronics appliances and also the telecommunications smart kind of technologies. So these diagrams so the kind of strategies that being used in particular. Well, this is the kind of a building for residential the climate of in Korea require the provision of both heating and cooling. So that's why in design that we try where possible to maximize the use of passive design, to use the natural ventilation during the mid-seasons, and where possible, that winter seasons that we introduce as much as possible solar into the interior space. And on the active system that we use the ground source heat pump to provide the kind of heating energies during the winter time. So overall, the building actually can achieve that zero carbon performance with the aid of that PV and also a small wind turbine to achieve that zero operations, zero carbon operations year round. But I think the trick is still that we need to bring down, as I said, the demand. So without this kind of exercise, it could hardly possible that the PV on the roof itself can actually provide the kind of electricity enough to drive all the kind of system that needs to be decarbonize the residual energy use. This is another project been done almost 10 years ago in Hong Kong. This is a kind of low-rise office building. We call it zero carbon ZCB, zero carbon buildings in Hong Kong. I mean, here again, we would want to use the concept of from low carbon. I mean that as I said, the government actually here have introduced a lot of low carbon requirements and also low carbon design in the adopt in the industry. But if we want to move down to the zero carbon, we have to work further on that. In particular, we actually have adopt the behavior change. I think that's important. That I mean, in the old days, I mean that when air conditioning is not that popular, that we use a lot of mechanical ventilations. But we find it quite difficult in these days to promote this because I mean people's behavior or culture change. In order to achieve that zero carbon, we have to reverse that process. So that's why I mean that in this particular project that we actually introduce this high volume low speed fan in order to provide kind of thermal comfort requirement during the sometimes, and to decarbonize the whole things because it's, the facility, the places for office and also exhibitions, we have to use to get kind of a continuous supply of electricity. So for that we rely on biodiesel, mass kind of energies. So we actually have introduced the first, I would say, biodiesel that powered by the waste cooking oil to provide the kind of energies for that. So in total, the PV and the roof provide around 30% of energy, whereas the remaining 70% of energy are provided by the biodiesel or bio energies on that. Another zero carbon building in Japan. In interest of time, I'm not going into details, and they're also applying a lot of technology to arrive at that. So I mean, we know that a lot has been done in the past, but what about the kind of long-term decarbonization situation of the entire society? If you look at this, it actually tells you the truth that the future doesn't look that promising at all. Because I mean that the building actually still use a lot of energy. That these numbers are the kind of energy use intensity in Hong Kong and also in Korea and Singapore. I mean the climate is an issue, and more importantly, as I said, I mean the quality, living quality or living standard actually have been improved significantly during the past few decades. That's why I mean the kind of energy use of the EUI actually keep on rising in the past few decades. So in order to achieve that zero, that we have to look from a more scientific way. So assuming that we have to get that 2050 zero carbon objective, we have to work from this trajectory. So the industry, and that in particular those professional institution here, that including the Green Building Council here, where I'm one of the director, is developing this kind of science-based trajectory decarbonization pathway for the industry to decarbonize. So you can see that we still have a lot of gap to get to zero. So at different junctures, we need to have different measures, and that measures has to be underpinned by either the regulations or be facilitated by the industry to implement that. So that's why that other than using that, I would say, science-based targets kind of pathway, we have to develop this roadmap. I mean, this is equally important. I mean, there are many, I would say, economy in this region have developed this kind of roadmaps for the buildings against the kind of instrument that I've just mentioned. So I think gradually that you'll see kind of convergence on different economy here to use this frameworks, including this one that's been developed by Global Alliance for Buildings and Constructions, whereby they create the short-term, mid-term, and long-term kind of policies on the kind of instruments that I mentioned. But what's different is that if you look at the UI, and they're different. Some actually starting from very high levels that they need to take a very drastic kind of measures, whereas some countries that are doing quite good, and in particular China and others, actually they're starting from relatively low kind of UI. So I think that kind of measures the kind of extent of the measures actually whereas with the economy or cities. New building is that we have a set of standard, and of course existing building, as I said, is equally also challenging, that we have to start from there. I mean, what we learned in the past few years, that many of this actually can be handled by change in the behaviors of our building operators, and also, I mean, more importantly, the behaviors of the corporates, when they actually procure, when they actually manage the assets, in order, to encourage the partners, be it the contractor, developer, or the investor, or the tenants, you work together to get that sort of synergies to arrive at zero carbons. Because I mean, existing buildings is quite difficult. Start from the hardware. You have to start from the behaviors, and I think more importantly, the kind of synergy that created from different stakeholders. So quickly, I mean, move even further, down the line. So what's next when we say the next wave of this decarbonization process? We know that inevitably we have to think about this carbon capture or sequestration scheme. We know that we need to develop smart infrastructures which not only decarbonize the building, but also the entire I would say the system from transport, and also from the waste that we generate in order to achieve that ultimate goal. So I mean, this are becoming hot topic. I mean, in this part of the world to create more clean energy. We know that algae is very good at absorb carbon dioxide. Well, in fact, a lot of lab or a lot of school research center here have actually studied on how we can harness or capitalize this hydrocarbons and convert that into the biofuel. Remember that I mentioned earlier that the zero carbon we operate here in Hong Kong actually use biodiesel, which I think with the help of the industry actually can be generated by this algae. So algae actually can also be integrated, embedded into our building system, in particular on the facade. I mean, that these are the kind of products that have been made in Germany and patent. We work together with our partners. I mean that it actually serve dual purpose. First, I mean that the algae actually help to shade the solar. At the same time, it help when it being cultivated, and that algae, when harvested, that can be converted into fuel, which can be used for other purposes. Of course, if you scale it up, it can decarbonize the entire, I would say, the power plant or other heavy industry where the carbon dioxide will generate an amount. Likewise, that a lot of activities, in particular in Japan and also in Singapore, a lot of research work or collaboration have been happening, trying to capture the carbon dioxide and sequestrate underneath the ground. There are many kind of different technologies, but what I think the current drawback of this is that it still will take a lot of energy in order to clean up the kind of carbon that's been emitted in the atmosphere. And then low carbon infrastructure is also very important. In particular, I mean that digital will actually be seen as kind of a hope for many industry. In the building industry in particular, I mean these kind of AI, smart digital energy plan management are becoming prevailing. Actually, most leading developer or building owner or asset manager, they actually when they manage their portfolios, they will use this kind of digital management system like this one that we develop for our partners. We call it Neuron. We actually help to manage the operation of building. It's not only about visualization of the energy use. It's more about using the AI or machine learning kind of technology to optimize the use of a facility. I think more importantly that to inform, to advise the user how or where they could help to reduce the energy in the daily operations. So these are becoming more and more popular with the help of BIM, Building Information Management System. This kind of technology become more and more powerful. And I think these days that with the inclusion of I would say the IoT, preventive maintenance or other predictive kind of operation are becoming feasible and more feasible. So there actually is also a kind of way out for our existing building in order to revitalize it or regenerate it, and I think more importantly to sustain it for a much longer time spans. I'm not sure that whether we could still keep the building young for 100 years, but definitely that if with the help of this kind of technology, it's not that difficult, that we maintain our building system as their highest, energy efficient standard. Of course, there are some other, district level kind of system that can help to reduce the energy use, including this district energy kind of system being implemented widely in Singapore and also in Hong Kong, where I mean that, as I said, that air conditioning account for over 50% of energy that used in commercial buildings. Likewise, that more and more kind of a project or initiative can be found in these regions on handling the waste, organic waste, food waste, and also the sludge, the waste water that we generate daily, and convert part of those waste into the energies. I think more likely in the future that we are not only relying on hydrocarbon. I think what we need to rely or switch or transform into another new form of energy sources, which is the hydrogens. I think globally, if we take that 2050 seriously, that hydrogen technology is something I think inevitable. So this year, in particular, the recent years, this vision actually a lot of kind of research and also pilot projects have been in place in order to test this technology. But of course, that we still need to address the issues of availability of green hydrogen, and more importantly, I think, is how we could address the issues of health and safety, which I think is a major, one of the main concern by the public, if not the controller, the government. So I hope I could answer these questions. Of course, I mean, as I said, this was only the beginning. We could not have all this answer, in 1 day or 2. I mean, that it probably take us 3 or 4 more decades until then we can have a full pictures. So before I end my presentation, I actually have a video to share with you in Arab, that how we see the kind of future of building will look like. So I hope you will like this. I mean, basically, it's our visions of the future, and then it actually compile a lot of ideas how the future of building look like. I mean, these actually can be downloaded from our company website if you're interested. By all means, have a look and see the detail. So thanks of all. This end of my presentation. I'm happy to take any questions from you.
Thank you, Vincent. Thank you very much. And now I think we have many questions, and Karen and Stephanie will be the moderator for this session.
Thanks a lot, Vincent. Definitely, we have quite a lot of questions in the Q&A session. The first question that I want to ask you is more about that the energy produced. Can you give us a little more details about how electricity is produced in this country, in Vietnam, Thailand, East Asia, Australia? Can you have a little bit of details about that?
I think that's a good question. I think supply side, I think is still kind of areas that energy generation it's a big kind of carbon emission sources. I think at the moment the majority is still using coke fire. I mean, coke fire is still the kind of major source of I would say energies, electricity, to produce electricity, primary energies for producing electricity. For more, I would say, developed city like Hong Kong, Singapore, or Japan, that they use natural gas. So I mean that it's cleaner. Although it's cleaner, it means, I would say, 50% less, the carbon, but still it's still hydro, it's still fossil fuel kind of sources. So natural gas, I would say, is actually intermittent stage before we can come to the ultimate kind of zero carbon. So, but for those less developed country or economy, majority of them still at the I would say the primary stage of using coal fire. Although that somebody actually is thinking of, why can't we move quicker, jump, bypass that natural gas directly to renewable? That's actually a kind of questions, a kind of a debate that's been happening in this region. Of course, there are many other issues other than cost. For example, that renewable itself, even the PV itself, when you manufacture, you create the kind of PV, you still embed a lot of carbon in that PV cell. So not that many people actually 100% plot that PV kind of options. So that's why that given this kind of a constraint or restrictions, the government here are now doing what we could, including the government of Hong Kong and also metropolitan government of Tokyo, to use more kind of incentive to like feed-in tariff to encourage kind of more people to use to install renewable, be it building integrator or install in some other locations. But I'm saying that renewable will still account less than, I would say, 1 or 2% of overall energies. Although in some other places, in particular you see in China, they actually probably move faster, and hopefully they can live forward and bypass that natural gas kind of intermittent stage and to that ultimate goal.
That's perfect. Thanks a lot for the comprehensive information, Vincent.
Vincent, I have another question that is so very relevant, but a bit long. So I'm trying to be clear on reading it, right? During the Green Building Week at the Shanghai World Expo 2010, Ms. Zheng Shi from China Academy of Building Research said, in most cases, adopt conventional technical strategy or appropriate technical strategy can get the same effect as high-tech strategy, such as natural ventilation, natural lighting, heat insulation, buffer layer design measures, sun shading and ventilation is the essential point for reducing air conditioning energy consuming. So 10 years later, and when we're seeing your building, the video you show us, yeah, what are you thinking about this recommendation?
Indeed, this is very important, very imperative. I mean, as I said, that when we think about the low carbon building or zero carbon buildings, I mean, the first thing we have to think about is how to reduce the demand. So I would say conventional or our traditional way of designing or building or constructing building, applying more and more kind of passive design, be it shadings or natural ventilation, is very important. But our challenge here is not about the design or construction itself. It's actually about the culture of the people. As I said, I was saying in the old day when the AC air conditioning is not prevailing, I mean, people can survive even without the mechanical ventilation, right? They can still survive primarily using the natural ventilation from the window. But nowadays, because I think there's two things that we have to study. First is our urban context. In the old days that we are not living at the high rise and very high density kind of built environments. If you get a chance to visit Hong Kong, you can actually see from the backdrop of my background, you can see that in that kind of context, natural ventilation to produce comfort constraint. So we have to study the context carefully and see how or where or to what extreme that we can go by adopting that I would say passive means as much as possible. So I mean, I totally agree that that actually exactly is the first step that we have to take on board when we design and we promote this kind of zero carbon or low carbon kind of practice. And as I said, that technology or construction or design aside, how we could change the mindset or change the behaviors of people that come challenge also.